think we are live now. Are we? Let's wait for people to join and then we can start, I guess. Yeah, so let's start with the first problem. So let's start with the first problem, I guess. NIT, the cleaver is in town. Okay. You are given an one indexed array of n integers a and integer z. You can do the following operation any number of times. Select a positive integer I that I is, then simultaneously set ai to ai or z, z to ai and z. Oh, bitwise operation. In other words, let x and y be the current values of ai and z, then set ai to x or y, set z to x and y. Find the number of a maximum possible value of the maximum value in a after any number of operation. Statement is very ambiguous. Let me open up open board. Laptop lagging. Let's just open up. So you're given one indexed array of n integers a and an integer z. You can do the following number of times simultaneously. Set ai to ai or z and set z to ai and z. So we have been given, where is my, so we have been given an array and an integer z. Select an integer and in others set ai to ai or z and set z to ai and z. So we can take any index ai and set it to ai or z, and then we can set z to ai z. So there are some set bits. Our value of z will always decrease. And our value of ai will always increase. What we have to do here? And the maximum possible value of the maximum value in a after any number of operations. So I think we just need to check ai or z. We can just check ai or z with all the elements, because in the first operation we will have the maximum value of z, and that value of z will give us the maximum element. So the observation is only one operation is sufficient, because after using one operation our value of z will decrease, right? So we don't care about the second value. We only care about the first value, and we will OR the first value with all the elements of ai and choose the maximum element among that. So I think that should be the solution for this. So let's try to code this out. We have 2 3 5 5. The first O and then z. You just keep answer it. We have 7 13 11 31, and I think last is also 36, but the last one is not correct. The answer for last one is 4 8 2 something. We have 4 7 9 something. Why is it so? Oh, max of not x here it should. I guess we let now go to 3. So let's submit this. So let's move on to problem 2 now. For a collection of integers s, define maps of s is small as we know what maps is. Whatever. The universe can be represented as a one indexed array of length n. Yeah. The universe can be represented as a one indexed array a of length n. When NID snaps his finger, he does the following operation on the array. He selects positive integers l and r such that L is between and W is equal to max of AL up to AR. Then for all I, he sets AI to W. We see the universe is destroyed if and only if for all A is equal to 1. The minimum number of times NIT needs to snap his fingers to destroy the universe. That is when the minimum number of operations NIT needs all the elements the array equal to 0. Is it? he will need at most 2 operations, right? Yeah, solution for A is very simple. You don't need to, like, if you want to prove the solution for A, you can show that after the first operation, value of Z will only decrease, right? So if your solution is to do AI and Z something in the second operation, it was useful to do in the first operation already, because your Z only has some specific set bits, right? And you are basically transferring these bits to array A. So after using one operation, some of these bits will maybe get erased. So it's optimal to just transfer these bits in the first operation. Second operation onwards, the efficiency will decrease, you can say. So I think that's a kind of intuition. That's not a hard proof, but I don't think it's that hard to think about, right? You can easily think about that. Let's make a new page for a second. I think the max number of operations required here will be 2, because so basically the question is, you have been given an array A, and you can take some subarray and set it to max of the subarray, right? And you have to convert the whole array to an array of zeros, and you have to tell the minimum number of operations that are required to do so. So in also, I think in worst case also, the number of operations required will be at most 2, because if you have something like 0, 1, 2, 3, 4, for example, you can take the whole array and set it to an array of 5s, and then just do another operation and set it to an array of zeros. Yeah, so the max answer is 2, I think, and otherwise you can always do it in 1, right? I think. If your array is all zeros, that is an edge case. If your array contains a 0, that is also a case. Otherwise you can always do it in 1 operation. Yeah, so it is always beneficial to like use Z instead of submask of Z. Exactly. So yeah, so if our answer contains 0, so like if our answer contains, there are some edge cases to consider here. So like if there are 0 zeros and then some subarray, something like this, then the answer to this is 1, because you can convert this whole to zeros. So basically what you can do here is you can consider indexes of non-zero elements, and if gap is 1 throughout, then the answer is 0. And yeah, you need to think about some edge cases here. So I think I will start with the first observation. If your array does not have 0, answer is equal to 1 operation. And another case that you need to check about is when your array is all zeros. When your array is all zeros, your answer is equal to zeros. So first I will code the second condition, then we will go forward. So you have all the arrays. If count d.begin, d.end is equal to 0 is equal to n, cout otherwise we know there is some non-zero element. So let's just ignore this for now. So now we know that our array is not all zeros, so now there is some non-zero element in the array. So there are two cases, like either all the non-zero elements are together. If they are together, we can apply just one operation here and convert them all to zeros. Otherwise, the condition is they can be like some bits apart. So something like this, 0, 1, something like this. So like if there are some gaps, then you can like apply an operation on the whole array, and then it will be something like x x x x x x. Then you can apply an operation on this and it will become all zeros. So now we just need to check if all the elements are together, or not. Yeah, so I will just keep indexes of all the elements, and if gap is more than 0 in any element, the answer is 2, otherwise the answer is 1. So that's how I will do this. So I will keep a vector, otherwise the answer is 1. Just print out 1 in the otherwise vector long indexes and then plus I. If b of I is not 0, I can push its index or push back I. Then for long I is equal to 1, I is less block size. If b of I if index of I minus index of I minus 1 greater than 1, then these are two separate arrays, then the answer is 2. I think that should work. Zero, 1 to 1. So let's take some like case now. Here it is working. So let's convert this. Let's do this 1 to 0. The answer is 1 here. This works fine. So let's move on to problem 3 now. Fishing Prince is playing with an array a1, a2, a3. He also has a magic number m. He can do the following operations on it. Select I, that is divisible by m, is an integer. Place ai with copies of ai by m. The order of elements in the example m is equal to 2, a is equal to 2, a is into 1, 1. In problem C, we try to do every element of A until its multiple is simplified more. We only have operation to first. I'm still trying question 3. No idea. Select such that ai is equal to ai single. AI is divisible by m. AI is divisible by m. So in problem 3, we have been given an array. And we have been given an integer m. So replace ai with So we have two operations. In operation 1, if there is an element, let's say a of I is equal to m times t, that is ai is a multiple of m, then we can replace it with t m times, right? This is like it is m times. So the sum remains same, right? Sum of this is still equal to ai. And the second operation is such that ai is equal to ai plus 1, ai plus m minus 1. Replace these m elements with a single m into ai. Sort of, for example, this. And the second operation is if there are m similar elements, yes, these are t, these are m t's, then you can convert it into m into t. Yeah, sure. So you can break down an multiple of m, or you can join some elements together. Is it just useful to concentrate on multiples of m? For example, if there is some element whose not multiple of m, let's say this is O prime to m, then will this element ever change? For example, if m is equal to 2, this is 3, we have 4 here, then will this 3 always remain in the array, or will this ever change? It will change, right? For example, if we have 6 here, it will become 3 into 3, then this can become 6, it will remain 3, so the elements can get swapped. Rahul said in problem C, we have to try simply every element of array up till it's possible to simplify it, not dividing it to m pieces, so that we only have operation 2 left to perform. Won't it give us TLE? Why do we have to apply operation 2 then, right? We can just apply operation 1 and compare the arrays, because it's possible that there is only one simplified version. So my initial approach was that I was thinking that if any element ai is co-prime to m, it will remain unchanged. But I found a sample case where it was wrong. So I found a sample that is, let's say 3,6 and m is equal to 2. Here you can break this 6 into 2 threes and then join these two threes. That is, it will become then 6,3. But you can observe that the simplified version of these arrays is same. So simplified version of this array is also 3 threes. This is also 3 threes. So I think if you keep applying operation 1, you will soon reach an array which cannot be simplified anymore. So if simplified version of 2 array is same, then the array A can be converted from array B, I think. That's the problem, right? So for example, if we take this 1 2 2 4 2, there is 2, I can convert this into 2 2's, this into 2 2's, so it will be 5 2s here and 5 2s here. So why do we need operation 2? I think operation 2 is not required. No. What I mean is I will also simplify array A and I will also simplify array B. And if these two arrays are similar, the answer is yes, right? Why do I need to apply operation 2 anyways? I don't think operation 2 is required. Please let me know if I am wrong somewhere. Why is operation 2 required anyways? Yeah, let's see why can we TL in operation. So we have AI equal to 10 the power 9. Yeah, we can get. What is K? Yeah, now I see your point. Why operation 2 will be required. N is less than 5 not 10 the power 4. AI is this. M is this. But the thing is, why will it TLE, right? Why will it TLE? Because M is 2, it will have at every element can be broken at most 30 times. Let's say M is equal to 2. M is equal to 2 and your elements is to the power 30. So it will break into 2 the power 29 elements. It will break into 2 the power 22 times. Then 2 the power 28, 2 the power 28. It will have 2 the power 30 elements in the end. Like, so my observation is correct. Now we need to see how we can implement this. So I think the observation is simplified forms of array A and B will be same. That is, if you apply operation 1 on array 1, right, it will be something, let's call this new array small a, and if you apply operation B, sorry, if you apply operation 1 on array B, it will form some new array that will be small array B, and these two arrays should be similar. But the problem now is you cannot simplify these arrays manually. You cannot simplify these manually, because if you're, let's say, AI is equal to 2 the power 30 and your M is equal to 2, then it will TL you obviously. So now you need to smartly do these operations, or you can smartly check. Operations required is, yeah, so we cannot decompose them manually, right? Operations required will be 30 only, but you cannot, like, you need to keep a map to keep track, right? You cannot manually expand into array. So your max elements are 10 the power your max elements AI is equal to 10 the power 9 and your M is equal to 2. So like you will need at most 30 operations, at most like around 32 operations at a max, I think, to decompose the whole array. But you cannot like manually decompose it. You need to you need to like keep a map to store the number of elements. You cannot like expand manually into an array. That will TLE. So you can decompose this in operations, and you can keep a, I think, a segment tree or something to like keep adding these elements. So that we will have to see how we'll do this. So let's think about that as well. So if we have an A, we have an B, we will start with the first element and we will go on to decompose it, right? We'll go on to decompose it and we will store it in a map. The number of elements that it formed, we will store it in a map, because these new elements formed will not be a multiple of m anymore. Similarly, we will decompose element 2 and we will store these in a map. And then we can keep pairs. Then we can keep some pairs in a map or something and we can compare them. So now it's just implementation, I think, how we implement this smartly. So I hope you get the point what I'm trying to say. So for example, if I have a equal to, let's take an example from the question itself. Let's say 1 2 2 4 2. 1 2 2 4 2. So I will keep a map. So first my frequency of 1 will be 1 here, then it will be, I will decompose this, it will not decompose any further. It will be frequency of 2 is equal to 2, it will decompose. Frequency of 2 is equal to 1 here, frequency of 2 is also 1 here. So I can just combine these two now. So now my frequency of 2 will be equal to 2. Then I will decompose this, it will give me more 2's. So now my frequency of 2 will be equal to 4. Similarly, this will decompose further and it will give me how much? It will give me one more 2. So now my frequency of 2 will be equal to 5. So now I can compare this. I will keep a vector in which I will store this, I think, 2 5, and then I can apply similar operation on my B array and I can compare these two arrays to check if these are similar or not. So let's try that. Yeah, so operation 2 will not be required at all. So I will check how many times m is divisible. It will have that many elements. Yeah. So I will keep a vector of pairs. First I will take in the two arrays. Yeah, that matters. So that's why I will keep a vector, I said. I will keep a vector here. That's why I said not map, but a pair of vectors. So I will keep a pair long. Let's say double A and double B, and say new A or simplified A, just into A, sim B. Let's just start with them 0, 0. I initialize them with take in n and n. I take in vector A, then I take in K. So now I have my two arrays A and B. So now I need to compute simplified of A, simplified of B. So in the end I can just return if simp of A is equal to simp of B. Simplified version of A is equal to simplified version of B. So now let's compute simplified of A and simplified of B. So long I equal to is less than plus I. My current element will be something like md par x. I will be md par x value that is t. First I will form I will form m par x entries. I need to compute this md par x. I will keep temp variable. When later I can arrive. The leftover element will have t. So I need to compare it with the last element of my vectors if they are similar or not. If side of a dot last dot back dot first of 5 current is equal to now I should do current into n, right? Current is equal to if my this element if simp of a dot back dot first is equal to a of I, that is these two elements are similar, then I need to add of a dot back plus equal to current, else we can just insert it. So of a dot of I and current, and you can do the same thing for B. Then you can just compare if these two are equal. Yeah, so I think this should work. Simplified of AB I think we fucked up somewhere. Is it working? Oh, annum. Oh, okay. Yes, yes, yes. Oh, yes. It's okay. You can try to submit this. Runtime error. Oh, I defined the sizes. So dumb of me. Yeah, good work. So, to explain once again the solution, the thing you need to observe is that operation 2 you don't need. The operation 2 is just like it is just combining the elements that you have split up, so it is not required at all. So you can, like, if you have an array A and if you have an array B, you can just simplify them as much as you can, and it is you can store the simplified form in form of the key pair values, right, in a vector. So you can just like go on splitting them, and you can store the simplified form as key pairs, and then you can just compare their key pair values. If they are equal, then the arrays are equal, otherwise they are not. So for example, if you have 1 2 2 4 2 and you have 1 2, what is that in the problem? You have 1 4 4 2, right? So you have 1 4 4 2. So you will first store 1 comma 1, then you will check 2 comma 1, so it will be 2 comma 1 only, because 1 and 2 are not equal. Then you will check again, then it will be 2 comma 1, and now 2 are 2 similar, so you can add these and it will become 2 comma 2. And similarly it will be 2 comma 2, right? 2 are again similar, then you can add these two as well, and it will become 2 comma 4. Then again it will be 2 comma 1. You can see these two are similar again, 2 and 2, so you can add these again, and it will be 2 comma 5. Similarly here you will start with 2 comma 1 comma 1. It will be 2 comma 2. These are not similar, so they will stay the same, otherwise these will be 2 comma 2, and these will get added, right? So it will be 2 comma 4. Similarly 2 comma 1 here, these will get added again, and it will be 2 comma 5. So now you can see that these are similar, right? This array and this is equal to 1 comma 1 and 2 comma 5. Similarly your second array will be 1 comma 1 and 2 comma 5. So these are same, right? So their simplified forms are same, so the answer is yes. So that's the approach. So let's move on to problem D now. M is equal to 2. 2 will compress to 1 comma 1. No, I am oh yeah, 1 comma 1. 2. Yeah, like I explained wrongly, but like you get the point, right? So like that's the thing. Yeah, so as like what's your name, Khabo pointed out, like 2 comma 1 will be if 2, it will split to 1 comma 1, so it will be 1 comma 2. So I'm wrong at that front, I guess. Yeah. So like I explained the example wrongly, but the the solution approach was correct. So like you can apply the same approach. So let's see problem D now. Not 1 comma 1, it will be 1 comma 2, right? So let me explain this once again for my clarity as well. So we have 1 2 2 4 2. We have 1 4 4 2. Earlier I was splitting into that, so I can split into two copies, right? So this is 1, so it will stay 1 comma 1. It will be this is 2 into 1, so it will be split into two copies of 1, so it will be 1 comma 2. These will get added, these will be 1 comma 3. It will be 2. This is again 2 into 1, so it will split into two copies of 1, so it will be 1 comma 2. These will get added once again, it will be 1 comma 5 now. Similarly here it is 4 into 1, so you can say 2 square into 1. So basically it is of form m the power x into t, then m the power x copies will be formed of t, so it can be shown as t comma m the power x. So if your value is, if your a of I is equal to m the power x into t, then t copy then m the power x copies will be formed of t. So here it is 2 the power square 1, so it will be 1 comma 4. Again it will get added, it will be 1 comma 9. Similarly here it will be 1 comma 2, and it will be 1 comma 11 in the end. You can do the same operations on array B and you will get the same result. So like you can convert your every element into t the power mx form. If your v of I is equal to m the power x t. So that's basically the approach. So let's move on to problem D now. And if I get the time, I will also try to solve problem E. So a permutation is an array consisting of n distinct integers 1 to n in arbitrary order. For example, 2 3 1 4 5, but 1 is not a permutation. 2 appears twice in the array. Yeah, so we have been given a permutation. We are given a permutation of this for integers ij such that I is less than j is less. Define min of ij as minimum of k equal to I, and this is build an unstructured graph of n vertices the number 1 to for every pair of integers. So of ij is equal to ai. Max of ij is both there existing of and shortest path from vertex to always the path. The shortest path always is. So I get the problem. So you have been given a commutation. So 5 3 1 2 something like this. And if you check a subarray, if the subarray, if the endpoints of the subarrays are maximum, if these are minimum maximum or maximum minimum, then there will always there will be edge between, if this is a1, this is a2, this is a3, this is a4, this is a5, then there will be edge between a2 and a4. That is, there will be edge between 2 and 4. So you have something like this, and you have to tell the length of the shortest path between node 1 and node n. So how can we do this? I don't think it's possible to recreate the whole graph, because if you try to recreate the whole graph, you will need O of n square time if you try to do it brute force. So I don't think we need to create the whole graph. There is some kind of observation here that will help you solve the problem. Is it possible to recreate the graph smartly? Because if you have one, how many nodes will one have? Because if you try to recreate the graph, if you let's say if your array is something like this, 1 2 3 4 5 6 7, then your array is strictly increasing, like then every sub array will represent edge. So there will be in total n square edges here, right? Around n square edges here. So I don't think it's possible to recreate the whole graph. That will be very, very dumb. Think about it. Uh, Very special nodes are n and 1. Right? This element n and element 1. Because I think all the nodes will pass through. I mean, if there is a 1 here, right? And you have some edges on this side, and you have some edges on this side. They can never pass, right? If you try to draw something like this, there will never be a edge from, let's say this is group A and let's say this is group B. There will never be a edge from group A to group B. Can you like see that? If there is one or an n here, because your extremities already lie inside, so you can never have a max or a min both at the same time. So if your 1 or n lie inside, your group A and B will never have an edge between them, right? So if this is your group A and this is your group B, and if 1 or n lies here, then first it must have an edge to 1 and n, then it must have an edge to group B. Are you able to see that? What are the time complexity required? The power 5 not 10 the power 5. Yeah, so I think that is, yeah, so I think, yeah, A and B will be like disjoint set. You can never have an edge from A to B if there is a 1 or n inside. So I think you can split it up here. You can split it up here and find shortest path from this to this and then this to this. Another thing is, do you split on both? Hmm. Do you split on both maximum and minimum element, or do you split on only? Let's try to run a sample case to get the answer. The answer for this is 6. So let's try to, is 7, 7, 4, and 3, 5. So So we need a path from 7 to 9. Obviously there is a 10 in between. We cannot do that. There's a 1. So let's split on the 1. So there is a 1 here, so we cannot obviously have a path from 1 to 9 directly. So first we need to find the minimum path from 7 to 1. So answer from 7 to, then answer from 1 to, let's not write it as this. Let's like keep an edge here. Let's write it as answer from 1 to 4, answer for 4 to 10. Then the minimum element in this is 4. So I can write here answer of this is 1 comma 2 plus answer of 2 comma 4. Answer of here the minimum element 4 comma 10. Not 4. Will this work? We need to find min or max. Write the closest min or max. Not your one and that part is correct, right? So if there is 1 and n in between, we cannot go further. We have to first find the shortest path to this node and then to the further node. And this so let's try on the minimum thing. The minimum here, so minimum of this is 1 4 plus. Obviously, if the gap is 1, the answer will be 1 1 now. Here's a bigger 1 plus 4 4 common. plus 6. So we will just keep doing on the smallest element, right? And if these are the endpoints, then we can check. So I think the solution is kind of recursive, but how can I implement this? Now I need to like implement this. How do I implement this now? First, let's take input, then we'll start from. Let's keep map because it's a permutation, so you can check the position using that. So now we need to do recursion. So how to recursion? Let's think about that. So first element will be n and 1. First, we've been given an array. We'll split on the positions of 1 and n, or we just split on the first position. So like I'm confused between two things. Like we have two elements, max and min. So who do we work upon, or do we work upon both at the same time? can keep a seg tree to find min-max first of all. Do I need a segment tree? Do I need a tree? Let's keep a segment tree. Oh, give me the max. Yeah, I am reading this segment. This will add code a big no. Yeah, I will think about that. Don't spam, bro. Min of this. We have infinite. I have two. Now I have two. Filing. Giving error now. It compiles. Oh, why now? Oh, now I have some segment keys. Let's populate them. 3, 1. Pause dot. So we have two segment trees now that will give us the min and max. We have a map that will give us the position of the value. Let's just keep it I for now. And now we need to define our recursion. How will we recurse? Let's follow our example only. Right. If gap is if gap is more than 2, then the answer is 2 there. So let's think about this now. F 7, 4, 8, 1, 10, 3, 5, 7, I have 9. I will first take the middle point and start from there. I will find the minimum on the left side, I will find the minimum on the right side. And if the gap of this is right, so first I will find a minimum in here. If gap of this is more than this, the answer is 2. The answer is 2 here, is obviously. And then I will find this thing, and then I will find this thing. So I will again find the middle here, I guess. Let's swap positions of 2 and 3 in 5, 7, 10, 5. First I find, so I will start with 7, 9. Right, so let's define our basic recursion. Why? Then I find, for every recursion I find one minimum element. Then I check its left side, then I check its right side, the minimum. So here I will find 4 here I will find 2. I know the answer for this already. Answer for if gap is more than 2, then the answer is gap is more than 2, the answer is 2 of already. Then I need to recurse on the answer for this point. I need to recurse for the answer for this point. Then I get 4, 7, and I again find the middle point here. Yeah, I think this will work. Let's try to implement this one. Yeah, passing by segment tree. Do I need to pass in segment trees as well? I need to find max min of commutation. So do I need to pass in segment trees? I don't want to pass in segment. It will look ugly. Yeah. Pass now as well. Then passing. So let's define the function. First, long L So now I find minimum of L comma R. I will call segment. So I don't need two segment trees, right? One segment tree will suffice. I'm just need one. So let's find the minimum index. So min index. Let's find the minimum element. Dot query. Querying com of. And I find its index. Index of this will. So I know its index. Let's also put in the base condition. If L is equal to R, then I know answer at 10. L is less than equal. Else if L is equal to R plus L is equal to R minus or L plus 1. These are adjacent, then the answer for this. Otherwise, find the answer will be plus L comma X. That much. We wrong. Good night. The element is Hello, bro. My mic is on. I find the minimum element. We need maximum. I need to find the maximum because it is the minimum already. There is already an edge. Maximum. Hmm. Okay. Makes sense. All this I can pass along parity. I don't even I need to prefix it. Keep two arrays prefix. You can just alternate code it. So my solution is now. So I will keep a parity bit. So I will start with the position of 1 here. So if I have 7 4 8 1 6 10 2 5 3 and 9, I will start with the position of 1 and then I will keep a parity. So first I will find min and now I'll try to find max. So I will find max on both sides. So for example, here I will find 10, here I will find 8. So I will add 1 to answer here. Then I will change the parity. Now I have found 8. Now I will try to find the minimum. Now we'll try to find the minimum. So minimum here is 4. So I will find 4 here. So I'll again add 1 and I will again find minimum on this side. Minimum here will be 2. So I will add 1 again. So I will start from the 1. So the approach will be if I will start from the minimum. Then I will try to find maximum on both sides. After I have found those two maxes, I will try to find minimum. And again, I will try to find max. I will keep alternating. And as I only need to find min and max on prefix and suffix, I can keep 2 arrays instead of segment trees. 4 arrays instead of segment. That will work. हाँ मतलब वही तो आज वो लाइक मैं पैरिटी इसलिए कर रहा हूँ मैक्स मिन के लिए मैक्स उठाना मिन उठाना so let's update the prefix first prefix by my then I can like, I think I can keep a lambda function, like prevent so many values. So I will keep a lambda of I. I just need to pass one. I just need parity. Pass net parity. Parity of one means that I need to find because left will find things on the left side and find things on the right side. Parity will max or min. Our answer will be first left. Parity will be 1. That find max plus first right. Cursing left. If it is equal to 0, then there is no left to traverse. So is if parity is equal to 1, I need to find max. So I will find prefix max. So long index is 0 of minus opposite. Right, because I need to find the max of it. Then I can just recurse left 1 plus recurse left position अपने को मिल गई है index and parity is now switched, so parity is detection auto. Can I not use, can I not use recursion? Lambda functions में cannot use recursion. Cause everything लंबी हो गई है. I think this question took almost an hour. Yeah, we've been swimming for 1 hour and 40 minutes. Quite long. So 1 plus f. Talking about. Okay. Hope this does not PLE. I use normal recursion. Try this out. You learn everything. Was not declared. Oh. First. Copy all this. Limit is equal to 0 if parity is not max. Cool. Works. Oh, let's give 6. I think that's correct, right? 6. Fingers crossed. 01146. Yeah, looks like a charm. submit. Hopefully this does not TL. So we solved 4 problems. Last one took almost an hour. I think streaming slowed me down. But so everybody has solved 4 problems. Oh, all fifth. So let's also see the 5th one. I will not solve this one. I think the stream is already too long. The stream is around already 2 hours. So I think I will try to like read the problem, try to get some intuition, and try to give my thoughts on the problem. So we say an infinite sequence A0, A1, A2 is non-increasing if and only if, yeah, that's correct. Is an infinite right and down grid. The upper left cell has coordinates 0, 0, rows are numbered from 0 to infinity, top to bottom. Columns are numbered from 0 to infinity, from left to right. And there is also non-increasing infinite sequence. A0 you are given A for every pair of x and y, the column with y is less of x. There is one doll named column y. Of a y is less than. So we have been given a grid. Have been given, and it has some. It is A0. Let's say. So cells here, cells, if a value of A0 is let's say 5, then 5 cells are covered white here. So there are 5 cells, then let's say 5 again, then it can be 3, can be 2, then it can be 0. So like the number of white cells is decreasing as the array is non-increasing, and after a of n all the cells are black. All the cells after a of n are black. Initially we start with the doll on cell 0, 0. We have to do and select and remove and place a doll on x, y plus 1 and x plus 1. uh, so we can remove this doll and place a doll here. Place a doll. Right. So I think you can use some kind of DP here, right? Where uh, DP of I comma j equal to DP of I comma j plus 1 plus DP of j comma I plus 1, sorry, I plus 1 comma j and plus 1. I think you can use some kind of DP. What that means is if you know the number of moves, required to remove all the dolls from this point, right? If you know the answer to remove all the dolls from point 0 comma 1 and 1 comma 0, then the answer of cell dp of 0 comma 0 will be equal to dp of 0 comma 1 plus dp of 1 comma 0 plus 1. That are my initial thoughts on the problem. And now how do you find this? Because the answer will be, this will be n square, I think. So the n is 2 into 10 to the power 5. So we have to find it in n. So now we need to like somehow optimize it, find some mathematical formula, find some pattern and optimize this. So how can we optimize this? There must be some mathematical operations. I am not able to think about it right now. D took a lot of time. So yeah, the approach is this only. You have to like kind of deep. How do we optimize this? That's the mic is on. So let's try to, we can try to write a brute force and try to observe the mathematical formula for this. But I'm not in the mood right now, so I think I will make a video on this separately. If you guys want, let me know in the comments and I will make a video on this separately. But yeah, the solution is this only: some kind of DP, some kind of recurrence relation between f of ij and f of ij plus 1 and I plus 1 common j. So basically it can be seen like, try to think about this. Uh, Basically there's a doll here and you take 2 moves, then you again take 2 moves, again take 2 moves here. So basically you are covering all the paths. You are covering all the possible paths that lead out of this grid. So you just want to count the number of moves it takes for this. So yeah, I will make a video on this separately if you guys want, and if you guys have a doubt, do let me know in the comments, and I will see you guys in the next live stream. Maybe I will do one in the coming weeks. That will be more on the easy side, I think.